Right. So when we're looking at complex fractions, what we mean is that our numerator and or our denominator contains a fraction as well. And we're going to be going through some processes to simplify this. So we're going to be doing more multiplying rational functions, adding rational functions, subtracting rational functions, dividing rational functions, as well as factoring and simplifying. So this kind of wraps everything that we've been doing so far into one nice, neat little package. All right? There's a couple different methods that we're going to be using based on the type of questions that we see. Okay? The first method, you can read that on your own. The first method, what we're going to do is we're going to focus on when we don't have any addition or subtraction of fractions. Okay? I want to show you the difference. See how I don't have any fractions being added or subtracted here? But I do, I'll do it again here, but I do here. Okay? So I'm going to show you a second method with this that's going to be better than the first method when we're adding and subtracting. Okay? If you just have monomial fractions or the denominator of one of the fractions is adding, then you can just use it. All right? So what we're going to do is we're going to go back to the basics of what a fraction actually is, and a fraction is division. A fraction is division. If I have 5 over 7, that's just 5 divided by 7. A fraction is division. Okay? So we're dividing the numerator by the denominator. So when I look at this, instead of seeing it as a fraction over a fraction making a really big fraction, think of it as my numerator divided by my denominator. And that makes it a lot less overwhelming and a lot simpler to kind of parse through and then go through the steps. So then we just have to ask ourselves the process for dividing fractions. How do I take two fractions and divide them? I need to change it. Do what else? I need to multiply by the reciprocal. So I leave my first fraction, 5x squared over x plus 1. Change it to multiplication, and then write the reciprocal. And now I just have one big fraction, all multiplied together. So then we look to factor and simplify. 5x squared is pretty much factored. X plus 1 is factored. X plus 1 is factored. 3x is already factored. So that worked out easy. So now it's just what simplifies? What can I cancel out from the numerator and denominator? X plus 1. Anything else? I can get rid of an x. Because I have x squared in the numerator. I have x in the denominator. Leaving me with 5x over 3. That's it. Factored completely and in simplest terms. Sometimes we'll factor and we won't be able to simplify. It just is what it is. It happens. That's fine. But you need to factor completely regardless. To factor completely regardless. And the reason is when we move into rational functions, there's important pieces of information from rational equations that we can only get if it is fully factored. If it's not fully factored, then it doesn't do us any good. And so that's why when we're simplifying rational expressions, when we're solving rational equations, we want to make sure that once we've kind of reached the end, it's completely factored so that then it's useful to us. Now, this one has two fractions being added. We're going to use that same method again. It's going to be a little bit longer than the second method, but I want you to see the comparison of why I use a different method. It also leads into something that we're going to be doing later. Okay? So before I can take my numerator and divide it by my denominator, I have to have one term instead of two. So I need to simplify each of these, here and here. So how do I add or subtract two fractions? Same denominator. So if I look at x squared and y squared, what's my least common denominator going to be? X squared, y squared. X squared, y squared. So how do I turn 1 over x squared into a fraction with that denominator? Multiply by y squared. Y squared, y squared. What about the other fraction? X squared. Because that's what's missing, right? Okay. What about for my denominator? xy is the LCD. So we multiply by what they're missing. Oops. Multiply by what they're missing from the LCD. So I end up with y squared times 1 is just y squared. X squared times 1 is just x squared. And then I get my denominator, x squared, y squared. That's my numerator. Denominator, 3y plus 3x over xy. So now I have them condensed down to one term each. That's our goal. Condense it down to one term each. And then we're going to go ahead and now we can multiply by the reciprocal. Treat it as division. The numerator divided by the denominator. Y squared minus x squared over x squared y squared divided by 3y plus 3x over xy. Keep, multiply, reciprocal, and then we want to look to factor and simplify. Okay? So I've got one big fraction. I wanted that to be red. Please be red. Thank you. I've got one big fraction now. So can I factor y squared minus x squared? I need to factor x squared minus, I need to factor y squared minus x squared. Absolutely it does. Two terms, perfect squares being subtracted. Y plus x, y minus x. xy is already factored. Okay? X squared, y squared, that's pretty much factored. What about 3y plus 3x? GCF of what? 3. Leaving me y plus x. Now we look to simplify. What can I simplify? Anything else? X and y. I've got an x up here, I've got an extra one down there, I've got a y up here, I've got an extra one down there. What's my final numerator? Y minus x. What's my final denominator? xy3. I'm just going to throw that 3 in the front. It's all multiplication, commutative property multiplication. Okay, so we had first the process of simplifying the numerator and denominator, then the division, then rewriting the division, then factoring, and then simplifying. Which is fine. It works. But there's a little bit of a faster way. Okay? But again, we only do this, the second method if I have that situation. Okay? What it is what we're going to, instead of finding the least common denominator for the numerator, simplify the numerator. And then find the least common denominator for the denominator, and then simplify the denominator, and then going through the whole process of multiplication division. What we can do is find the LCD of all of the fractions in our expression and multiply everything by that least common denominator so that it actually cancels out our fractions and leaves us with a single fraction that's not complex. So what I want you to look at is I have denominators of y squared, 3, y, and 6. What is the least common denominator of all 4 of those going to be? y3. That's a common factor of all of it. I want the least common denominator, least common multiple. Imagine you were trying to do 1 over y squared plus 2 over 3 plus 1 over y minus 5 over 6. All of that together.
Okay, so y3 is 9.
pretend I was trying to do this. What would my least common denominator be? 3y. Because if I have 3y, well then how do I turn a 6 into a 3y? I can get a y, but I don't want to divide. 12y is closer, but 12 is too big.
9.
I heard parts of it. I can't turn a 6 into a 9. Keep the 6 as a 6, and I can turn the 3 into a 6. How do I turn a y squared into a y? Yeah, but I can't. I want to square root that whole thing, and then it's not going to be the same. So what's the variable going to be? Overthinking it. What did I do here to get a common denominator? Okay, so I had x squared and I had y squared. I had x and I had y. I multiplied those together, right? Okay. Now think about, I have y and I have y squared. What's my least common denominator of y and y squared? Where? Y, not y squared. Okay? That's my least common denominator for all of them. Y squared. All 4 of those fractions have an LCD of 6y squared. So now, I'm going to write this big, just so that you can clearly see what's happening. Okay? 2 over 3 over 1 over y, 5 over 6. Okay? Alright? My LCD is 6y squared. What do I need to multiply the first fraction by so that it gets that denominator? Oh, actually no, back it up, sorry. We're not even going to do that. We're going to multiply everything by 6y squared. Everything by 6y squared. And 6y squared. Okay? So what's going to happen is this is going to be distributed property here, here, and there. 6y squared multiplied by everything. And what's going to happen is I'm going to make these go away. Because then they won't be fractions anymore. It's going to be a magic trick. You ready? That gets multiplied by 6y squared. 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 Okay? Everything gets multiplied by 6y squared. So then I have that multiplication, that multiplication, that multiplication, and that multiplication. Looking at the first fraction, what simplifies? Looking at the second fraction, what simplifies? So I can simplify the 6 and the 3 to just end up with 2, right? You can multiply 2 times 6 with 12. You'll get the same thing, right? Okay? What about with this fraction? What simplifies? Y. What about with this one? What simplifies? Do I have any denominators left? No. That's the goal. Find the least common denominator of all of them. Multiply by that least common denominator to all of them. And it will simplify. If it doesn't, you didn't do it right. So with my first fraction, I got rid of the y squared. So what am I left with? 6. Second fraction, I simplified the 6 over 3. What am I left with? 4y squared. Denominator first term, I simplified y squared with y. What am I left with? Y. And the second term, I canceled out the 6's. What am I left with? 5y squared. Now I have a fraction that is not complex. Well, we're going to factor. Whether or not we can simplify is wait to be seen. So factor the numerator. GCF of 2. So I get 2. And then I'm just going to put the squared term first. So I have 2y squared plus 3. Just use my commutative property of addition there. So I factored out the 2. Can't factor that anymore. Okay? GCF for the denominator. Y. So I'm left with 6 minus 5y. Do I have any common factors to simplify? Nope, so that's it. Fully factored and completely simplified. Fully factored and completely simplified. Ready to do another one? So we're going to do something very similar. Okay, we're still going to apply that method, but we're going to have to also keep in mind that we have expressions with negative exponents, and we need to rewrite them with positive exponents. So it's going to take something that doesn't look complex, and it's going to make it complex. Okay? So if I want to rewrite x to the negative 2 as something without a negative exponent, what does our negative exponent law tell us to do? Yeah, make it a reciprocal, right? So 1 over x squared y squared. Write the reciprocal. So I have 1 over x squared y squared. My denominator. Only the x is going to the negative exponent, so only the x is going to be a reciprocal, so it becomes 5 over x. Same is true for the y. So now I have two fractions in my denominator that are being added together. So I want to find my least common denominator of all of my fractions, and I want to multiply everything by that. So if I have x squared, x and y, what is my least common denominator? That is for my denominator, but it does not include my numerator. Squared y squared. Because I just have to multiply x by xy squared and y by x squared y, and then they're all the same, right? So that's my least common denominator. So I'm going to multiply everything by that least common denominator. All three. Notice how I'm not doing top and bottom. I'm not multiplying x squared, y squared also by x squared, y squared. I'm not multiplying x by that. I'm not multiplying y by that. It's just the numerators. Because I'm multiplying the fractions. It's just distributive property. It's not converting it to an equivalent number. It's multiplying each of those fractions by that LCD so that we can simplify each of those fractions. And this is the method that's going to transfer into the next unit when we do solving rational equations. We're going to be doing the same thing, finding the least common denominator of a bunch of rational expressions and then multiplying everything so that they're no longer fractions, they just become expressions that are not rational. Okay? They're rational, but not fractions. So with my numerator, I've got this big fraction. What simplifies in my numerator? X squared, y squared, leaving me with what? Nope. Because that can't completely leaves me with what? First term in the denominator. What simplifies? X. Leaving me with 5xy squared. I still have an x left over. I only got rid of 1 in the numerator with the 1 in the denominator. The last term. Yep. All right. So now I don't have a complex fraction anymore. 1's already factored. Factor the denominator. GCF with x and y, leaving me with 5y plus 2x. Completely factored and simplified. It's going to take practice, which is why you're going to get Russ class time to work on it.